Hey everybody, it's MoNaCo here. Woo! I wanted to show you a working electrochemical cell. In this unit, an electrochemical cell takes a spontaneous chemical reaction, which I have in two halves of this battery, and creates electricity. This battery I've created essentially is producing 1.6 volts of electricity right now. So I just wanted to go through what each part of this battery is and what reactions going on in here to produce this electricity, this flow of electrons as to what's going on here. So on this left-hand side, we'll call this the first half cell, number 1, and then this one will be number 2, half cell number 2. Now in half cell number 1, let me move this cord a little bit. Oops, there we go. Half cell number 1, I've got a little strip of magnesium metal. Okay, so I have magnesium metal involved. In half cell number 2, I have copper metal involved. Now, magnesium, according to reference table J, is more active than copper. So magnesium will easily lose electrons and become magnesium ions. So I'm going to show that magnesium becomes magnesium positive 2 and 2 electrons. These electrons are actually traveling up through the wire, through my voltmeter, and back into the other side where the copper is kind of soaking them up. So the copper is soaking them up. Inside the solution there's a solution of copper sulfate. The blue color is because the copper positive 2 ions that are present. Well, the 2 electrons from the magnesium come through the wire, go down the copper piece here, in touch and build up on the end of the copper that's what's immersed in the water. And when the electrons come in contact with copper ions that are in the solution, becomes copper metal. Okay, so this is the 2 half reactions that are in play in this operating electrochemical cell. Reduction and oxidation. So oxidation is losing electrons, so we'll call this one the oxidation half reaction, or the oxidation half cell. And this would be the reduction half reaction, or the reduction half cell. When we combine both of these equations to get the overall redox equation, we're going to put everything on the left side of the arrow on the left side of the arrow. So I'll say Mg metal plus copper positive 2 ions makes, well, magnesium positive 2 and elemental pure copper. I've ignored the electrons because whatever electrons are lost are also gained, so it's kind of like they cancel out. If we want to go through the parts of the battery, I'll show you by picking up the camera here. So let's see. All right. So I got my voltmeter, which acts as my electrical circuit. We're still producing 1.6 volts. Then I have this thing. This is what they look like. So in this side, I have magnesium sulfate, and you can see the magnesium is reacting to become something else. So you can see little bubbles there. So the magnesium metal is becoming magnesium ions, and the electrons are traveling up through the magnesium anode, through the wire, into the voltmeter, powering the circuit, which is telling me, oh, I'm making 1.64 volts. Comes out the other side, the red wire, into the other terminal of the battery, the cathode, which is made out of copper. So batteries work because these two different metals, magnesium and copper, have different reactivities. Magnesium's more active, so it loses electrons easily, oxidized. And copper is less active, so it gains those electrons more easily. Now this thing in the middle is what we call a salt bridge. Because if electrons are moving through the wire and ions are being created and used, that means we have to have something for the ions to travel through. So watch what happens to the voltage on the battery when I pull the salt bridge out. Disappears, it drops down to 0. So the salt bridge allows ions to travel, and the electrical wire, the circuit, allows electrons to travel. So in electrochemical cells like this, the anode is always the more active metal, and the cathode is the less active metal. The anode loses electrons to the cathode. So in this way, we can say that electrons travel from the left-hand cell through the circuit to the right-hand cell. And that's kind of what an electrochemical cell does. This is a spontaneous reaction because the magnesium and copper, magnesium is more active than copper. So this creates electricity from a chemical reaction. The next one I'll be showing you is the exact opposite of an electrolytic cell, which I'll need electricity to run a chemical reaction. So thanks for watching.